So now with balancing equations, if you've watched the other videos that I posted on balancing equations, it's not much of a hard set of rules, but some tips I can give you to help you balance the equation. So a tip means it works most of the time, may not work all the time. So these are just some tips that if the occurrence comes, you can use these to help you balance the equation. And so equations are like recipes in chemistry. Just like you have recipes in food, you have recipes in chemistry. So with food, you have ingredients, you make something. In chemistry, we have chemicals, we make other chemicals. And so in the first example, we have nickel 2 sulfide plus oxygen gas gives us nickel 2 oxide and sulfur dioxide. And so the first thing you should always do is determine the number of each type of element on both sides of the reaction. So on the reactant side, we have 1 nickel, 1 sulfur, 2 oxygen. On the product side, we have 1 nickel, 1 sulfur, 3 oxygen. Because there's 2 oxygen from SO2 and 1 oxygen from NiO. Now the first tip is usually when you do this, you determine the number on both sides of the equation. That kind of directs you as to what to balance first. So as you see here, we see that only the oxygen is not balanced. So our first kind of thing to do is to balance the oxygen. And so what we're going to do is we have an even odd combination. So when we have even odd combination, you got to look for the common multiple between the two numbers. So 2 and 3, the common multiple is 6. And so what we're going to do is we're going to put numbers in front of the reactants and products, which are called coefficients. So right now, all the coefficients are 1. We do not change the subscripts. So subscripts don't get changed, only coefficients. So for example, O2 is something you breathe, oxygen, but if you were to change it to O3, ozone, it's something you can't breathe. It'll kill you if you breathe in too much ozone. So that shows you that when you change the subscript, you're changing the formula of that substance. Likewise, H2O is water, but if you put H2O2, it becomes hydrogen peroxide. Water you can drink. Hydrogen peroxide is not used for drinking, it's used for cleaning wounds. So that's why we do not change the subscripts, we only change the coefficients. And so here we have a 2 and a 3, so we put a 3 here. We have 6, so we need to put a double the number of oxygen on the product side, so we got to put a 2 in front of NiO and a 2 in front of SO2. Because now you see this 2 gets distributed to the nickel and to the oxygen. The same for this 2 gets distributed to the sulfur and to the oxygen. So now we have a total of 6 oxygen, but our sulfur and nickel have changed. Now we have 2 of those. Likewise, on the reactant side, our oxygen is changed to 6. But notice now the nickel is not balanced. So now we need to balance the nickel on the reactant side, and since both nickel and sulfur are together, we can put a 2 in front of that. And so now we have 2 nickel and 2 sulfur. So again, the 2 gets distributed to the nickel and to the sulfur. Now let's move on to example 2. Here we have a reaction involving molybdenum sulfide. Oxygen gives us molybdenum oxide and SO2. So again, the first step is to determine the number of each element on both sides of the reaction. We have 1 molybdenum 2 sulfur, 2 oxygen. 1 molybdenum, 1 sulfur, 5 oxygen. So now you see here that in this example, both the sulfur and oxygen are not balanced. So since we have 2 elements not balanced, the question arises, which one do we balance first? And this is where tip number 2 comes in. Generally, you want to balance the non-hydrogen oxygen elements first before you balance the oxygen hydrogen elements. So using that tip, we're going to balance the sulfur first. So since there's 2 sulfur on the reactant side, we need to put a 2 here to get 2 sulfur on the product side. So this 2 again gets distributed to the sulfur and to the oxygen. So now we've balanced the sulfur, but now our oxygen increased to 7. And so now we have a conundrum, because on one side we have 2 oxygen, on another side we have 7. And there is no whole number that you can multiply by 2 to get 7. So what I recommend we do, since oxygen is by itself, if we double the other coefficients, that will get rid of the odd number of oxygens on the product side. So again, let me say that again. Since oxygen is by itself, what we can do is if we double the remaining coefficients, that would remove this odd number on the product side, because we can't use fractions, we have to use whole numbers. So what I'm going to do is I'm going to double the coefficients. So right now in front of MOS2 we have a 1. If I double it, we put a 2. In front of MOO3 we have a 1. If I double it, we put a 2. And then here was a 2. If I double it, we're going to put a 4. And so now you see we have 2 molybdenum and 4 sulfur. And on the product side we have 2 molybdenum and 4 sulfur. But now you'll notice we have an even number of oxygen, because the 2 gets distributed to the oxygen as well, and so does the 4 as well. So now we have a total of 14 oxygen. So now 14 is easy, because if we have 2 oxygen and they're both on the same reactant, then we can put a 7 in front of the O2. And so this is the balanced chemical equation. Also, one thing to note is that the lowest common multiple between all the coefficients should be 1. If it's not 1, you have to factor out whatever's common multiple other than 1. So here we have 2, 7, 2, 4. The common multiple is 1. So looking at number 3, we have potassium peroxide plus water gives us potassium hydroxide, oxygen gas, and hydrogen peroxide. So again, we want to determine the number of each element on both sides. So we have 1 potassium, 3 oxygen, and 2 hydrogen. On the product side, we have 1 potassium, 5 oxygen, and 3 hydrogen. So now we notice here that the oxygen and hydrogen are not balanced. So the obvious question here is, what can we do? Which one do we balance first? We have oxygen and hydrogen, and here comes the next tip, which is typically when you have two elements or multiple elements need to be balanced, typically you start with the element that occurs in the fewest reactants and products. Again, you start with the element which occurs in the fewest reactants or products. And so in that case, we see that hydrogen is in 3, one reactant and 2 products, whereas oxygen is in every reactant and product. So with that said, we're going to start with the hydrogen and balance it. Now what we have to remember is that we have 3 hydrogen on the product side, 2 hydrogen on the reactant side. It's an even odd combination. So we need to get 6 on each side. And so to get 6 on each side, we're going to need to put a 3 here, a 2 here, and a 2 here. And so now you see we have 2 hydrogen and 4 hydrogen. That makes 6 hydrogen. So again, the 2 gets distributed to all 3 elements, just like this as well. But by doing that, now the potassium is not balanced, and we have a total of 2, 4, 8 oxygen on the product side. On the reactant side, we have 6 hydrogen, and we have a total of 5 oxygen. So to make 2 potassium, we got to put a 2 in front of here. So now we have 7 oxygen. So the only thing left to balance is the oxygen. Now again, here we have an even odd combination. We have 7 oxygen on one side. Well, not 7, excuse me, we have, 7 oxygen. And we have 8 oxygen on the other side. So again, this is an even odd combination. And we don't want to change the coefficients that we've already added. But if somehow we can make the reactants an even number of oxygen, then we have this O2 here that we can come up with the difference. So again, we got to make an even number of oxygen on the reactant side. And so when we get an even number of oxygen, whatever oxygen that needs to be balanced after we double everything, we can easily put something in front of O2. So now what I'm going to do is I'm going to double all the coefficients except O2. So instead of 2, we're going to put 4KO2, 6H2O, 4KOH, and 4H2O2. So now we have 4K, 12 hydrogen, and 14 oxygen on the reactant side. On the product side, we have 4K, 12 hydrogen, and we have, so far we have 4 oxygen, 8 oxygen, 4 and 8 is 12, plus 2, it's 14. So now we have a balanced chemical equation. So 4KO2 plus 6H2O gives us 4KOH plus O2 plus 4H2O2. So again, the reason we doubled it was because our last element to balance had an even odd combination, so we doubled it. All the coefficients except the one that just contained oxygen, we left that alone. And then when we did that, we came up with the right number of oxygen atoms. Finally, our last example, we have Mg plus N2o3 gives us MgO plus manganese. So again, we want to determine the number of elements on both sides of the reaction. So we have 1 magnesium, 2 manganese, 3 oxygen. On the product side, 1 magnesium, 1 manganese, 1 oxygen. And so here we notice that the manganese is not balanced and the oxygen is not balanced. But remember, our tip was first we need to balance the manganese, the non-oxygen atoms, then we balance the oxygen. So to make 2 manganese on the product side, we're going to put a 2 in front of manganese. So now we have 2 manganese. Fairly straightforward. Now we have 3 oxygen on the reactant side, 1 on the products. We need to put a 3 in front of MgO. So now we have 3 oxygen on both sides. Now the manganese changed, or magnesium changed to 3. So in order to make 3 magnesium on the reactant side, we put a 3 in front of Mg. So now we have a balanced chemical equation. So here we're going to look at number 4 here, in which we have P4O10 plus H2O liquid gives us phosphoric acid. And so again, we want to start by counting the number of each element on both sides of the reaction. 4 phosphorus, 11 oxygen, 2 hydrogen. And on the product side, we have 3 hydrogen, 1 phosphorus, 4 oxygen. So now we see that everything is not balanced. So again, the rule of thumb is we start with the non-hydrogen oxygen elements. So if we start with that, we need to balance the phosphorus first. So we're going to put a 4 right here. And when we do that, we get 4 phosphorus, but we also get 12 hydrogen and 16 oxygen. Because again, that 4 gets distributed to the hydrogen, phosphorus, and oxygen. Now you'll notice that the hydrogen and oxygen are not balanced. So the next rule, or the next tip I should say, is to balance the element that doesn't occur in too many reactants and products. So using that, we know that we should balance hydrogen next. And so hydrogen, we have 2 hydrogen on one side, we have 12 on the other. So to make this 12, we're going to put a 6 in front of H2O. And so the 6 gets distributed to the hydrogen and to the oxygen. And so now we have 12 hydrogen and 16 oxygen. So now we have a balanced chemical reaction. And so that's all I had for balancing chemical equations. In the next lecture, we'll be looking at stoichiometry. So given the mass of a reactant, how much product is formed, or given the mass of 2 reactants, how much product is formed as well.